All right, can everyone see my screen?
Yep.
All right, awesome. Then we can begin. All right, welcome to the review seminar. Okay, so the first topics we'll go over today are going to be memory models and our function design recipe and doctrine. So basically, hold on. Sorry. Yeah, okay, so if you guys aren't already familiar with the memory model in Python, it's kind of a way for us to track like the execution of a program. And so, for instance, on your exam, you're most likely going to get these questions within multiple choice. And so, maybe, for instance, at a specific line, they'll ask you to check the memory model of a program. But okay, right here, we can work through this multiple choice question right here. So let's see, after this code is executed, which of the following statements on the right are true? And we can check all that apply. So like a hint for this question is for this. You kind of want to draw it out, just in case if you keep track in your head, you might miss something. But draw out the boxes. For instance, X will get a box which will point to some value, right? Y will have an ID which points to a box which gets some value.
Excuse me, are you talking? Hmm.
Yeah, I am talking. Yeah, yeah. Okay, but yeah. So I'm gonna give you guys a couple of moments to just go through this question, and then afterwards, you guys can just type out the answer in the chat. Let's say I'll go over the answer at 113, 114. So I think that should be enough time for everyone to think about it. Okay, so it's 114 now. I don't see any answers from you guys yet, but that's okay because we'll go through how you guys will solve it. But just for reference, the correct answer is A, C, and D. And so right now we're just gonna draw out the memory model to see how why it's A, C, and D. Okay. So on the first line, when we look at this, right, we have the variable x, right? And so the variable x will get an ID, which will point to some box in memory containing the value given to x, right? Which in this case is 10, right? So I think important to note is that you don't want to draw a box, the box for x, you don't want to put 10 in it. Rather, it's x has an ID which will point to 10, right? So it's kind of like X doesn't have 10, but it has the ID which will tell us, where the value is for X. Okay. So originally we have that. And so now we're also going to do the same thing with Y. So Y will have some ID, which will tell us the value for Y, which in this case is 100 here. And afterwards for Z, Z will also have its own ID, but instead of just pointing to like some value, right? Now it's going to point to this list, which is containing the IDs of X and Y. And I think this is important to note that you don't want to make the mistake of putting in the values which are given to X and Y at this time into here, right? Rather, you want to give the IDs of the variables X and Y. Okay, and now afterwards, this last line, we're going to see that X's arrow here is now going to point to Y's value, 100, right? And so when we set X is equal to Y, what we mean by that is the ID of Y is going to be given to X, right? And so because they have that same ID, they're going to point to the same value in memory. Okay, does that kind of make sense to everyone? Yes. Okay, awesome. Great job, guys. All right. And so now we can see that from here, both X and Y are going to refer to the same object in memory. And why is that? It's because they have the same ID, right? And now X and the first element, or sorry, X and the second element in Z are also going to refer to the same object in memory, right? As well as Y and the second element in Z will refer to the same object in memory because at this moment, uh, if you guys recall with Python lists, we can access each element in the array with these square brackets followed by the indice where it's located, right? And so Z1 is not going to start at the first one, it's going to start the second one because the lists are zero indexed, which means that our first index will always be zero. So something to take note of. Yeah, so might be an easy mistake to make if you don't remember correctly, but yeah. So hopefully this makes sense to all of you guys now. All right. And now the next thing we're going to go into is the function call stack. So within the context of like a Python function, you have stack frames, right? And so you can kind of think of each stack frame for each function, kind of like having its keeping track of all the variables and functions defined within that context of the function. And then in addition to that, you also have your global stack frame. Okay. And so let's go move through this question. So over here, we're given a function f and a function g. So f is a function which takes in an int and returns a Boolean value, right? And g takes in an int and returns an int. So you can see obviously here, if x is greater than 10, then we're going to return true. If it's not greater than 10, right? If it's equal to or smaller than 10, well, then we'll return false. And then with g, just returns x times the value of 2. Okay. So let's go through this and let's answer the first question here. How many stack frames will be on the function stack during the execution of g on the following line? All right. So before we even move to this function, right, we want to remember that we will have the global variables in our initial stack frame, right? So the functions will get their own ID, and then the variables we define will also get their own ID as well. So yeah, if you guys know how many stack frames will be during the execution of G, remember during the execution, because after executing, those stack frames will be removed. So if you guys have an idea or like maybe have an answer, you guys can just type in the chat how many you think it is. at 2. No, it's not going to be 1, and I'll show you guys in a moment. But yeah, the correct answer is 2. The correct answer is 2. So now let's go and see why. All right. So remember that we have initially our stack frame containing our global variables, but after when we execute G, right? When we execute G, we want to create a new stack frame for this function call, right? And so maybe you would have thought 1 if it's after the execution, because after the execution, we get rid of the stack frame. But during the execution, we still have it, right? So then in the end, the final answer will be 2, right? After we end up returning a value, right? After we end up going to this return function and actually, this function returns a value, then we'll clear it and then we'll be left with just 1. All right. Okay, now let's move on to this one right here. So let's think how many stack frames will be on the function stack during the execution of G on this line. So I'll give you guys a moment to think about it, type your answers in the chat as well. So I think something important to note as well is that, the order of which functions are executed, right? So in Python, like if a function is passed in as an argument, um, that's always going to be executed first. And so what I mean by that, like in this case, right, we're calling f of g of y, right? So what's going to happen is that g of y is going to be first evaluated before f is even evaluated, okay? And so during the execution of G, again, we'll only have 2 stack frames, right? Because we haven't started executing F, so that we haven't created that stack frame yet, right? So, and then once we finish executing G, right? And when we go to F, we'll still have 2, right? Because then G is going to be cleared off the stack, and then we'll have F, which is a new stack frame for us to go to. Hopefully that makes sense to you guys. If you guys do have any questions, feel free to either unmute yourself and ask, or you can also just type in the chat. But yeah, for both of these cases, the answer is going to be 2.
Could you please re-explain why the second one is 2 as well?
Okay, yeah, for sure. So let's read through this again. How many stack frames will be on the function stack during the execution of G on the following line, right? So we want to recall that in Python, we will always evaluate the first function, right? Like which is passed in as an argument into the other function, right? So for instance, you could maybe if you have like a really big function like or something like a huge chain, you have like f of g of h of I, right? You're always gonna evaluate the inner one first. Does that make sense?
Yeah.
Right. And so on this case, we're considering during the execution of G, right? We always have to go this stack frame for all our global variables, but then when we call a function, we make a stack frame for that function. But after we finish executing G, we're going to get rid of this stack frame, right? Because it's after we return a value, the stack frame for that function will get cleared, right? And so when we end up evaluating f, the answer will still be 2, right? Because we got the value from G already, and then it was cleared. So now we only have a stack frame for f. So then we will have 2. Does that make sense, kind of?
Yeah, all right. Thanks.
All right,
Um,
awesome.
Hi.
Yeah.
I'm wondering, so could you give us a scenario where the answer would be different than two?
Yeah, for sure. Let me think for a moment. Okay, I don't know if you guys have done recursion yet so far, but basically like a recursive function will like call itself, or this is kind of hard to explain without like writing it out, but like um kind of in the sense that you have a function which requires the previous stack frame stack frame in order to return something, right? So suppose you have like some function and then instead of returning like a value, it will return itself, right? So eventually what it's gonna do is it's gonna keep calling itself many times until it gets to some case, some like base case. I don't know, like say for instance you want to like do a Fibonacci sequence, right? You'll start out with the numbers 0 and 1, right? And then to compute the next one, you'll like um you basically compute the last two, right? So if you want to compute like oh the fifth Fibonacci sequence number, right? You'll need to compute like you need to compute the third and the fourth, right? And so when we're like executing like the call for the fifth one, we'll have stack frames open for the third and fourth. Um yeah, and so in those cases we'll have more than two, I think, yeah. But I
Okay. So basically, like if we're questioned on function call stack, the answer will be two in our case.
no, not always. Like if there's no function being called, then there will only be one function or like one call stack, right? Um but yeah, that's a good question for sure though. Um it kind of the like in these cases, right? In this case, because we only have it's just a simple function call, right? So after this is returned, then
Hmm.
this will be called, right? So yeah, we'll only end up having two for this scenario, but
So what about one only having one?
well, only having one. So in the case where you only have one is where you just have your global stack frame, right? So maybe you have like imagine that this line, can you see my mouse?
Yeah.
Yeah, imagine that this line right here, y equals g of x. Imagine
Hmm.
that isn't there, and imagine that isn't there. So imagine the entire program ends after we declare x is equal to 2,
So
right?
it's just the global.
Yeah, yeah, where we're just like defining these functions and variables, right? Then we'll only have one stack frame.
Right. So what would the question be? The question would be like during the execution of the given the given body.
Yeah, yeah. During the execution, it'll ask you most of the time, like up to this line, or how many stack frames will be at this line, like during the execution of this, or like so it's important to know during the execution we will still have that stack frame. After the execution, we won't because it will return something. Yeah, so just
Okay.
just be mindful of that. Yeah.
So if there's no like the y equals gx, then during the execution of the body, it would be one because there's one global.
Oh,
And
oh, okay, shoot. Sorry. Thank you for catching my mistake, Daniel. Um, or yeah, wait, yeah, this is a very good, not mistake, but thank you for giving this example. So like, Daniel, he gave an example where like a function calls another function. So in which case that will like create multiple stack frames. Yeah, this is much more straightforward than my Fibonacci example, but yeah, thanks Daniel for that. But yeah, if that's a pretty good example in the chat for when you will have like multiple stack frame calls greater than two.
okay.
Yeah.
So like um if it's after the execution, it's al always gonna be one, right?
Um, like if you are after the execution of a function, right? Then that function will return something, and like the stack frames for that function will be gone. So for say for instance, like in the example that like Daniel gave, right? So we have h of x, right? And g of x will call h of x, right? So, but like when we're executing g, right, we're going to have three stack frames, right? But the second that g returns, right, the stack frames associated with it, which will be like the first stack frame for it, and then the stack frame for h of x, those will be cleared, right, after execution. So basically, like, after executing any function, like the stack frames for it will be cleared.
So it's 0.
For a function, right? But like then you'll still have your global you'll still have like the main stack, the main stack frame, right? Like if your entire function or like sorry, if your entire program ends, then you'll have still zero stack frames, right? Because right, y- it ended. But like if at any case like a function is done running, then just clear everything associated with it. So for instance, like if all functions have like returned something, then you'll only have one because you have just the global stack frame left. Does that kind of make sense to you?
Right. So it doesn't matter how many during the execution. If it's after the execution, there will only be one, the global.
Yeah, basically, just like after the execution of a function, we don't even consider how many stack frames were created during its execution because either way, we know it's going to be cleared. So in the end, we'll just be left with like the global stack frame. Yeah,
Right. Okay. Thank you.
awesome. Very good question. Oh yeah, and Daniel also said, yeah, there's a nice multiple choice question, number 3 and 4 from the 2023 fall past final. Yeah, so if you guys have access to that past final, you guys could check out that question. But yeah, most of these you will not get it for written portion. You'll get it for like a multiple choice question. All right. Okay, now let's move on to the function design recipe. So I think function design recipe is pretty straightforward. There's three main components to keep in mind when you guys are going to design a function. And it's the header, the doctrine, and the body of code, right? So I think this part is really important because whenever you're going to get a written question, right? Whenever you guys are asked to write some code on the exam, you want to make sure that you abide by this function design recipe, right? Because that's also going to be like how they're going to evaluate you on your code other than your correctness. Okay, so I talk let's talk about the function header. Essentially what the header does is it just indicates to us the function name and what we need to put into that function. So what's going to be our arguments and what's going to be the parameters of them, right? And so that's what's passed through, right? And afterwards, we can tell us the variable type of the return value and the re name of the what return value we get, right? So, for instance, right, maybe if your function takes in like two integers and adds them, then you want to specify that, okay, it's going to take two variables. Here's what the first variable is called, the second variable is called, and what are the types of the variables, right? And afterwards, what type is it going to return? So that's kind of what the function header there is for. And then afterwards is the doc string. And so that's going to contain your written description of the function, right? As well as some test cases kind of um, outlining it. And so the you can specify that with like um the three quotation marks in Python to kind of create your doc string. And yeah, and then afterwards, obviously, is the actual code of the function itself, which is the function body. And that body of code will execute what you told the function to do in your doc string, right? You want the doc string to accurately reflect the actual code you've written. Yeah, so let's go through a couple examples of that, right? So over here, this is kind of like a general like template you can use, right? So as I said before, like you might not have two parameters. Maybe you only have one parameter. Maybe you have zero parameters, or maybe you have like more than this, right? But the main point is that for each parameter, you want to have the parameter name, specify what type it is, right? And afterwards specify the entire return type of the function. Okay? And yeah, in the doctrine, provide the description and the testing. Um, a lot of the times, like sometimes you actually understand the body of code written better if there's a test. Um, yeah, so specifically for that example call, right? You want to have the three arrows, call your function with some parameters, and then afterwards on the next line, specify what is the correct value for that function call. Okay. So yeah, those are the main parts of it. So let's go into an example real quick. All right, so we have this body of a function right here. I want you guys to kind of maybe think of a good function header that this that we can use for this function. And then give us maybe, yeah, give me a doc string, right? A brief description of what it does, and like an example of a function call for this function and what it would output. And yeah, I think for this, I'll give you guys 3, 4 minutes, 140, we'll go to the correct answer. But yeah, for now, just think about it. And if you have answer, just feel free to type in the chat. Um, so also this guys also should understand. You guys need to understand, what the code actually does before you can write a function header or a doc string or any examples, right? So a hint, right? We're taking the ceiling of the number of pencils divided by pencils per box. So think about that. Okay, can we take up multiple choice question 7 in winter 24? It's about stack frames. I don't think I have access to that question in winter 24. But if you send it to us, yeah, I think we can go over it once we cover like all of the other content after this. But yeah, we can for sure cover that if you have it. I unfortunately don't have the multiple choice question 7 from 2024 winter though. Yeah, but also just one more minute for this one, and they'll give you guys the answer. If you guys have the answer, feel free to type it in the chat as well. Okay, all right. So it's 140 now. Let's check out what everyone had. So we have one from Jaw Eye. Okay. So pencil stuff. All right, first of all, yeah, I'm not gonna lie, like you can have this, but like you're going to get docked marks for this name, right? The thing about your function header is you can't just name your function anything, right? That function name should mean something, right? So by reading it, I should have an idea of what this function is going to return. Pencil stuff, it doesn't give me like a lot to work with, but okay, let's check out the rest of this. So you have num pencils, which is an int, right? Pencils per box, which is an int, and it returns an int. Okay, cool. This makes sense, right? Because we're likely not going to have num pencils be a string, right? It's also probably not going to be a float value, right? The only thing in this case which makes sense would be for it to be an integer value. Okay, so you said it returns the number of boxes needed to store the amount of pencils when each box can hold an amount of pencils per box. Um, okay, yeah, I think this description is okay, yeah. Um, we could also say hold up to an amount of pencils per box as well too, right? Because it's not required for the box to be completely full in this case because we're taking the ceiling, right? So for instance, right? I'll just correct your first mistake. Instead of pencil stuff, we should probably name it something a bit better, something like number of boxes, right? And then you also need to have an example here, right? Of two example calls. So that could be improved. But other than that, the description seems okay in my opinion. Yeah. But let's go to the one possible answer, right? So we have a much more descriptive name for our function here. And if we follow that up by our description, and your description does not have to be long, right? If it's the simpler your answer is, and it captures the entire function, the better it is as well. Yeah, return the minimum number of boxes needed to pack num pencils if each box can hold up to pencils per box pencils. And then yeah, over here they also added some requirements, some constraints, right? Num pencils must be greater than or equal to 0, and pencils per box must be greater than 0. Which is also really good to add here. Only thing I would do maybe is I would also maybe add like an example call to this function, as well as what that function will return. So yeah, but you can see it does all these things here, describe the return value, mention each parameter, describe what the function does, and specify preconditions. Okay. Let's go through what would be a bad description. Okay. So a bad description does not include the implementation of the function, and the purpose of the doctrine uh, explains how the function does it, not what it does, right? When you're reading the doctrine, you don't really want to like provide all the information of how the result is derived. Simply, you just want to say what the function does, right? What does it take in? So over here, you can see this. It just tells us takes num pencils and pencils per box, divides num pencils by pencils per box, and applies this, right? Right. It's just telling us what we can already see here, but it's not actually telling us, the purpose of this function, right? Which is to return the number of boxes given the num pencils and pencils per box. But yeah, I think this is very kind of more of an easy concept, but also equally important for your exam because you will be asked to write a lot of code. All right. And yeah, now we can dive more specifically into the types of docstring tests. So we have type 1 where we have no mutation at all, and then we have a non-trivial return value. So basically something like, oh, um, like, okay, so I'll give an example of an uninteresting one where you're like, your num pencil is 0, right? And your pencils per box is, I don't know, some value greater than 0, right? In which case, every single time you'll get 0, right? So that would be kind of like kind of uninteresting, right? But this is pretty straightforward. You just give your function call and then give the expected return value. So nothing too crazy there. And for type 2 is you have some sort of mutation, right? Normally you have this for like a little bit more of a complicated function like this one. And then, for instance, maybe you have multiple like inputs, which maybe are objects themselves, which you defined earlier. But yeah, the general format is still the same, right? If you have an input, assign the input to the variable, and then call the function with this variable, and afterwards, you want to just give you the return value right afterwards. Right after it's called. So for instance, mutation in this case means like it takes this function is called on an object, and then it will end up uh, it will end up affecting that object in some sort of way. For instance, over here with nums, right? It's going to take in nums, right? But then afterwards, it's actually going to modify, right? Its given input. So in which case, afterwards, you want to just have another line calling nums, and afterwards show the result of that object that you mutated. Thank you, Daniel, for answering that question. Um, yeah, and so then the final type, or the type 3 we have, will return a dictionary. So everything else is the same, your description. But now you want to also compare the return value function with the variable above. Um, yeah. So for instance, right here, if we take scan menu, it will return the dictionary mapping each item name to a tuple according to the menu list. If the rating is greater than or greater than 5, then we map it to price -1, right? And so in the end, it follows roughly similar. But when we compare it, like because it's unordered, maybe the result will not look exactly the same. So that's why afterwards you want to just also like just list out the entire thing, what it will look like here. Okay, cool. Now I'll pass it over to Lucas and he will take on lists and help you guys prepare for this portion of your exam.
Okay, I will lead you to review the list and for loop part. Oh, everyone can hear me? Okay.
Yeah, you're good. Your audio is good.
Okay. Here. So everyone can see my screen share. Oh, it's paused. Okay.
Yeah, we can see. We can see.
Oh, can you see the move of the page?
Uh,
Or it's still
your screen, I think, is frozen. Can you try moving your mouse?
Oh, okay.
Okay. Now click slideshow. Oh, we can't see the slideshow. We can't see the slideshow.
Uh, let me check another website. Just 1 minute. Oh no, not string. Wait. Sorry, Sean, I think I have some issue with the slides. Can you do the slides for me?
Yeah, no problem. I can share the slides for you.
There
Just let me know when to turn new slide. Okay.
there you go.
Yeah. All good, all good. Yeah, can you see?
Uh, let me check. Stop sharing. Okay. Yeah, you can share now.
Yeah, I'm sharing. I'm sharing.
Oh, I didn't see it. Oh, yeah, I can. I can see it. Okay. Okay. Now let's start. So for lists, before I want to start to review list, I want to first show that what's the difference between the list and the strings. And I think the most important difference between lists and strings is that lists are immutable and the strings are immutable. So lists are immutable means that we can change it without like creating a new thing. So for the operation for lists, there are two types. The first type is we just modify the original list, and the second type is that we create a new list. So for elements in the side list, we can access using indices starting from zero. And from zero is the first element, and one is the second element, and one by one. But also we can start from -1 is the last element, and -2 is the second last, and then just one by one from right to left. And the third point is that a slice Lij creates a new list from elements in L, which means that and I and J, I is the I is the closed and J is open, which means that maybe like L03, it means that it creates a new list of L0, L1, and L2, but without L3 because J is open instead of closed. It's like a smaller but not equal to. And the fourth point is that the plus operator concatenates two lists together. And this plus operator is different from extend, which is that it will create a new list instead of modify the original one. Okay, Sean, can you move it? Okay, here's some built-in list methods. Um, for adding elements, we have three methods. The first one is append. We just add one item to the end of the list, and it's just modify the original list. And in insert, we add an item at index I, which is index, the first parameter. And item is the second parameter is the element we want to insert in. And extend means that we want to add every element in list lst2 to the end of the list my list, so that the lst2 has to be a list with which means it has a like square bracket. And these three methods all return none because they modify my list. And for removing elements, we use pop. A pop will remove the element at index, and it will return the removed element, but it still modify the original list. And if no argument is given, the method will just remove the last element. And then it's a sorting element. We can use the method sort. The first parameter reverse is equal to true or false. If it's yeah, it means that you want to sort it by ascending method or like decreasing method. And the key is your function, like your sorting function. I think you didn't learn lambda in this course, but you can write some function which defines the key to sort the list. Okay, and next. Okay, here's the exercise. It determines from these 6 operations which creates a new list and which just modifies the original list. And I will give you 1 to 2 minutes to solve it. Okay, so we know that pop and append, they just modify the original list. And slides, it will create a new list. But we also introduced that the plus operation will concatenate but returns a new list. And Shawn, can you move the slide? So we know that slice is a new list. And for the second one, A equal to A023, why it's a new list? Because it has a square brackets outside the whole thing. And if you saw a new square bracket as the most outside, you can just determine it's a new list. And A equal to A plus 4, 5 is a new list because it uses the plus operation. And the right 3 thing is not because the pop and modify, append, modify. And for the third one, B equal to A. So it just and then B0 equal to 2. So it just changed the index 0 of the list to 2, but without changing the whole list. No, but without creating a new list. Any question about this? I think this is pretty important. Oh, I saw like if B equal to A, does B creates a new list? No. In Python, B equal to A, B will just store the reference of A so that if you change B0, it will also change A0. They have the same reference. Yeah, it's typical for Python. Okay, and then it's for loops. So for loop is for iteration. It will iterate over, you can choose it over list or over string or even over dictionary or something. So, and X will be the current item in the list or string. So the easiest way to do the for loop in Python is just iterate over the list. And you will for list, it will just get first element, second element, third element. And for string, it will just get the first character, second character, and third character. But there's also another use of the for loop. We can iterate over the range. And X will take values from start to end incremented by step. So you can see the range function here. And the start is a start index, like a start point. It's can be index or something, and end is the endpoint, and step is like how much you jump from one, maybe from 1 to 3. Step is 2, and you should know that the start is closed, but end is open, so that it's like the index is bigger or equal to start, but smaller than end, not equal to end. And this range function is helpful when you're working with parallel lists, and we'll have some example later. What is a parallel list? It's like you have list 1 and list 2. You want to traverse both of them in the same time, and it's better to use range function here. And we can also iterating over nested lists. Nested list is like it's a list of some lists inside. So for like this example, it can first iterate it can iterate the list inside the list, and then iterate the element inside the inner list. Okay, and let me check do A equal to A plus 4, 5, create 2 new lists. Sorry, what do you mean by 2 new lists? I think it will just create a new 4, 5, and yes, but since you don't store 4, 5 in anywhere, it will just be removed or be deleted by the system itself. Yeah, yes. Yeah, 4, 5 is a constant, but so you don't need to, since it's not stored anywhere, you don't need to consider that it creates or not. You just need to know that if you store something, and then you can say it's create. Yeah, never mind. Okay, let's go to next slide. And here is a practice for list and for loop. It will ask you to return the number of elements in list 1 that are not in list 2. And duplicate elements are treated as different elements. I will give you 1 minute to think about it, since this one is yeah.
Lucas, do we want to have a 10-minute break? Maybe like also
Oh
during
yeah. We can
yeah.
have a 10-minute break now. And you can check we will check the answer for this after 10 minutes, and take your time.
Okay. In that case, we'll come back at 2:12 maybe. Yeah.
Yes.
2:13. Yeah, 2:12. Okay, it is 2:14. Lucas, you got this, yeah?
Yeah. Okay, let's start. So for this one, I saw some students type in the chat, and yeah, it's correct. And Sean, can you just move to the next page? Yeah. So here, the first thing is that you have to set a counter variable count to 0, and then you just traverse through the first list, or you can traverse through the second list. It depends on you. And oh no, you have to, no, it's not. You have to traverse through the whole the first list, and then you just check each element inside list 1 is inside list 2 or not. And you can just use the not in operation. It's very easy to use in Python. And then if you find it's not inside list 2, you just you just plus the counter to 1, plus counter with 1, increment by 1. And then at last, after you finish the loop, you can just return the count and you'll get the correct answer. Oh, let me check, will this work absent number if number not in. Oh, actually, I think that duplicate sentence is make us confused, but it's not a big deal. You don't need to care too much about that. You just need to traverse through the first list, and then you just check it's inside the second one or not, and that's complete. Okay, and let's check what's the result and output of this following code. I will give you it's a pretty short, so maybe 30 seconds. Okay, now let's go through the whole step. Oh, no, turn back. Okay, so for A, they first print A, so we want to check what is inside A. So first, we know that A is a list of 1, 2, 3 inside, and then A dot pop. So it will just pop the last element, and 1, 2 is a new A. And after append, it will append a slice from like zero, from 0 to 2. So it will just add a new element at the end of the original A, which is 1, 2, which is a list contain 1, 2. And for D, it just extend A with 4, 1, with a list 4, 1. So it will just add an element 4 at last and another element 1 at last. So for A is 1, 2, 1, 2, 4, 1. And for B, we know that pop will return the element we remove. So that since we remove 3, it will just return 3, and B has the value of 3. So it prints 3. But for C and D, since append and extend, they all return none. They return nothing. So that it will just print none. Yeah, you should know that it's like it will return something. It will return none, but not return an arrow. Okay. So this program has no arrow. Okay, let's go to next slide. What is the result and output of this following code? Yeah, so M is a nested list and result is a empty list. And you extend M with an element with a list only consists 10. So it will just kind of append a 10 at the end of the list and then traverse through the whole thing. And I remember I tell you that negative index -1 means the last element. So what's the result? I will give you 20 seconds. Okay, so the result is some students said it's D. Okay. And can you share the reason why you think it's D? Okay, I will give you some time, and I will first say that why it's arrow, not any other answer. It's because for each item inside the list, like for the first 4 items, they are just list. So that results append item -1. So that since the element is list, you can just get the last element of the list by -1 index. But when we go to the last element of M, which is 10, and just a number instead of a list, we cannot access to anything by just use the index -1 since their type not fit each other. So that it's a type arrow and it's an arrow. Okay, can you understand? And if you can understand, you can just type in the chat that why you think it's D. Okay, let's go to the next slide. Next. Complete the following function. Oh, it's okay. Shawn, can you just go back 1 page? Why it's C? Because we extend M by a list only contain 10. Since it's extend instead of append, so that the last element of M now is not a list, but just the number 10. So that when you traverse the whole M and traverse to the element 10, since it's not a list, you cannot access to the last element of a number by -1. This is a type arrow. Okay. Okay, do anyone has any question? If not, we
Could you
just
please repeat the explanation of why why 10 is not a list?
because the parameter of the item parameter of extend has to be a list. And here, like 10 is like this is a square bracket, which means that it is a list, only contain an element 10. And you extend this with M so that you just add the 10 to the end of the list M. but not like the first element of M. They are all with square brackets, so they're all lists. The last element 10, it's just a number. It's just an integer and it's not a list type. Yes, yes. Any questions? So yeah, you should be very careful that it's extend, not append. And yeah, now it's a question. So return the index of the first different element in list 1 and list 2. And just return -1 if list 1 and list 2 are different lengths or they are completely equal. I will give you one like 1 minute and 30 seconds. Oh no, just 1 minute. I think the time is yeah, 1 minute. So this question is like a parallel list. But the point is that they don't have the precondition that the length of list 1 and the length of list 2 are equal. So that before we use range to traverse it, we have to first check their lengths. And if their lengths are not equal, we just return -1. And since that and if the two lists are completely equal, just use the equal operation to check, and we just returns -1 as well. And then we just check if it's not in these two cases, we just check which index is the first different element. So that we just use the range to traverse, and then we check list 1 index I and list 2 index I are equal or not. If they're equal, we just go to the next iteration. It doesn't matter. And if it's not equal, we just return the I, which return the index, and it will just terminate the whole function. And we don't need to care the next several iterations, and it will just terminate. And also there's a case that if you can also put the list 1 equal to list 2, this case into at last, because since they're nothing like since their lengths are equal to each other and you traverse through the whole thing and all of the each element are equal to each other, so that you can just return -1 at last, and it will only reach there if they're exactly the equivalent. Okay, and I think I will pass to Daniel, and he will introduce strings and while loop for you.
All right. Thank you, Lucas. Let me share my screen. Can you guys see my screen?
Yeah, we can see. We can see.
How about this one?
Yeah, we can see.
Okay. So, okay, let's talk about string. So string is basically is a sequence of characters. So if you see something like ABC with a quotation marks, like between the quotation marks, so it's a string, okay? As simple as that. And then to initialize a string, you guys can do with the equal sign and then just put a quotation mark and then type the string that you want to like assign to the variables and then put another quotation mark. Like one is for open and one is for close. So basically there is an example here. So my string equal quotation mark ABC quotation mark. So that's how you initialize a string. And then if you want to print a character, like a single character, you can do by string indexing. So you can print my string 0. So it will print A. And if you do my string 2, it will print C. And there's also another method called string slicing, where you can like take a substring, like more than one character from the string that you already have. So wait, I don't think there's any example here. So yeah, basically you guys can do it's similar to list. So you can do my string from 0 to 2. So 0 and put a colon and 2. It will give you the characters from index 0 to 1. Yeah. And then one thing to remember is that strings are immutable. So that means that if you already initialize a string, so maybe this string ABC, it cannot be modified. So you cannot say my string 0 equals C, so that it can be CBC. No, you cannot do that. You have to make the whole new string, like another string. And then before we continue to the other string explanation, I want to test you guys on this question. So what will be the answer of this question? Oops. The string method reassign itself. No. Remember, string is immutable, so it cannot reassign itself. Someone said error, so why is it error? Oh, okay, that's my mistake. So just assume it's str instead of string. I just forgot to like remove the ing. Okay, assume it's str. Okay, D because of word 2. No, being assigned. Okay, let's just go to the answer. Okay, so the answer here is none because wait. Right. The answer is none. It is because that when you say uppercase the second word, so it will call the function uppercase the second. And then this word string is just a type contract. So word doesn't need to be string. So but the type contract is string. So the program expects the user to put a string as the argument, but it can be not a string. So there can be no error in this function. So it is not D, but it is E. Why is it E? Because look at the function. The function is not returning anything. So it should return none. And then another way to notice this is that you guys can check the type contract. So the type contract is the function will return none. So when you call uppercase the second word, it will return none, and then it will print the word none. So that's it. All right. Yeah. Let's move on to the next question. So now it's a string question. What is the result or output of running a Python file with the following contents? Oh, wait, hold on. All right, my bad, guys. So the answer is error because, yeah, we're modifying word to. So it's illegal here. So it should be error. Okay. Yeah, this one is wrong. Okay, okay. Yeah. The answer is error because you're modifying the word to a string that is
Hi.
immutable.
Hi, I'm wondering if you gave it a different variable, for example, like you assign it like to like A or something, you wanted to print A, saying that that was word to the upper, would that work? Because you're not modifying it?
Yeah.
Okay.
So are you saying that A equal word to upper?
Yeah,
Also, A will just contain the M, but in uppercase.
right.
Yeah, you can do that.
Okay. But right now it's error
Yep,
because,
true.
right, okay, yeah.
So it's error here. Okay, I will just modify the slides later. Okay, this one, I think it's similar to the previous one. But now instead of returning none, it return a string, but it's still error because we still modifying the string. String is immutable, cannot be modified. So remember, string is immutable and cannot be modified. Okay. String is immutable and can be modified. Okay. Next, we have how to manipulate strings. So with strings, you can concatenate two strings by using the plus. So you can do A plus B. So something like this, like A equal ABC. And if you say A plus equal D, that means A equal A plus the string D. So ABCD, it will output ABC. Similar to this one. You can also do print AB plus 34. It will print AB 34. Yeah, simple. And now we will talk about string methods. So in the exam, I think it will be very helpful if you guys know what methods are there for string. So instead of doing like multiple if statement to check, like if it's a small a, we make it an uppercase of the a, you can just do dot upper, or you want to make it lower, just do dot lower. So it is very helpful for you guys to know the string methods. So there are many string methods in Python. You're not required to like memorize all of them, but just know that if you think that this that is a common operation in string, you can expect that there will be a methods for that. So you can just look at your cheat sheet, like your help sheet, and find for the function, for the methods. So I will talk about 4 methods here. So first, there will be string.lower. So string.lower will like returns a copy of the string in lowercase. Remember, returns a copy of the string in lowercase. It's not gonna modify your string. It will return a copy of the string. And then string upper, just return the copy of string in uppercase. And then string.strip, it will returns a copy of the string with leading or trailing white space removed. So if you have like space ABC space, if you say space ABC space dot strip, it will return ABC because the trailing and the leading white space will get removed. So white space can be a space like blank space or a new line. And this will be very helpful for you guys when you guys deal with the reading file stuff, like the reading file material. Like, and then there's also string R strip. So instead of removing leading and trailing, you guys can just remove one just the trailing white space. Yeah, it's not very useful, but you guys can, it's useful for you guys to know that. And then many more string methods can be found in the string methods worksheets. So it will be provided in your exam help sheets. So no need to worry, no need to memorize. Just remember, if you guys think that it is a common thing to do in string, like in Python, there might be some method for it. Now I will like teach you guys how to read the documentation, because from my past experience, when I'm invigilating the exams, many of you guys, no, not you guys, like the past students ask me like, what is this? Like, is it a list inside a list? What is the slash here? And yeah, so many stuff. And how to read the documentation provided on the help sheet. I kind of forgot like which one will be provided, like the first one, like the split self, or the second one dot split with the list type, with the square bracket. So I just explain both of them. So the first one is dot split. So if in the exam you find that in the help sheet there is dot split self slash sep equal none max split equal -1, then it means that there's a method for a string, and the method is called split. So you can just call str, not str, like your string dot split, and then you don't need to provide the self, because self is just a keyword to just refer to itself, like to refer to the string. And then this slash, you can just ignore the slash, and then you have to provide the argument for the SEP separator and max split. But since it has a default value none, and the max split has a default value -1, you can also like ignore the arguments. Like you can say dot split, just say dot split. It will split by, I think, by the space. And then the next one is dot split, but now you have a square bracket sep and square bracket comma max split. So what does this mean? This is not a list inside a list. Okay, this is just an optional argument. So if you find that you have a square bracket, it means that the argument is optional. Can either provide the arguments, or you can just ignore the arguments, because that argument has a default value like this. The default value of step is none. The default value of max split is -1. Yep, and then you can just read what the function does by reading this. Return a list of the substrings in the string using sep as separator. Yeah, this is sep as the separator string. All right, so far, any question? If there's no question, let's just move on to the first example. So we have the function refers and capitalized vowels, and it takes one argument, that is input string, and it will return a string. Look at the type contract. So it will take string as an argument, and return a string as an argument, as the return value. Okay, I will give you guys like 2 minutes to solve this. And yeah. All right. I don't think like we have enough time to solve all the problems, so I will just guide you guys through the solutions, and let's look at the solutions. So if you find this like this is a hard question to do, I have some tips to like solve the problem, solve the question. So the tip is just solve this question in English, like make the algorithms step by step in English, and then you guys transform it into Python code. So let's see the function docstring. The docstring is return the modified version of the given string, refers to the given string and capitalize only the vowels and return the result. So we have two goals here. The first one is to reverse, and the second one is to capitalize the vowel. So let's break it down into two different goals, two different tasks. The first one is to reverse, and the second one is to capitalize. So reverse the given string, and to capitalize the vowel, we have to go through its letter in the input string, and then check if it's a vowel, and if it's a vowel, then capitalize the letter. So that's how you guys do it in English. Yes. And now we have to like code it in Python. So to reverse a string, you guys can do string slicing. You guys can do string slicing, or you guys can just for loop and like append the characters backward. And then to capitalize the vowel, let's see, go through its letter. So go through its letter. Go through means like loop through its letter, and then it can be done by for loop in Python. And check if it's a vowel. So check if it's a vowel. So if in English you guys found an if, that means in Python it's equivalent. Like there's also an if for that. And then if it's a vowel, then capitalize the letter. So that means that if you guys can somehow check that it's a vowel, then you guys capitalize the letter. So capitalize the letter, you can do dot upper in Python. And yeah, let's just look at the solution. So first, vowel is this one. Don't forget the uppercase for the vowel and the lowercase, because we have to take into account both cases. And then since string are immutable, you cannot like modify the result in the input string. So you have to make another variable for that to store the result. And now the first one is refers to the given string. Refers to the given string, you can do it by using string slicing. So you can do it by equal input string colon -1. It will like refers to the string. And then we have capitalized the vowel, so go through its letter. So you can just for loop for character in reverse string. So we'll go through its letter in the string, in the reverse string, and then you check if it's a vowel. So the way to check it is that you guys check if character is in vowels. So vowels contains A, E, I, O, U, A, E, I, O, U. So you guys check if the character is in that A, E, I, O, U. And then, yeah, if it's a vowel, then you guys append the result, append the uppercase of that vowel to the result. If it's not, you guys just append the character to the result. No need to make it uppercase. Why do we say modified version? Why does vowels include capitalized A, E, I, O? Okay. So why do we say modified in the docstring if the string is immutable? I think return the modified version of the given string. I think it just want to like, I think just the English. So it should return the other string, like the modified version of this string, not this string, modify the string inside the variable or something like that. It's just ending the English. It's okay then. And then why does vowels include capitalized A, E, I, O, U too? Because when you check character in vowels, you have to check for both cases, right? Like capital A is also a vowel. But if your vowels has no capital A, when you check if character in vowels, it will return a false. But capital A is also a vowel. All right, is everything clear? Or- Right, let's just move on to the next question. All right, the next question is to remove the consecutive duplicates. So it should return the modified version of the given string. It means that return the new string, a new string, and remove all consecutive duplicate characters, leave only one occurrence of its character in the string, and return the result. Remove consecutive duplicates. Okay, so for this question, we have to return a new string. Okay, just assume that said return a new string where all consecutive duplicates are removed and leave only one occurrence of its character. So the way to do this is that you guys have to find a way to somehow remember the previous character. And then you compare the current character and the previous character. If it's the same, then you guys don't need to include the character. So suppose it's AAA, let's say AAA. So the first one, the previous character is empty. So A is not equal to empty. So just append A to the result. And the second one, when you iterate through the second A, the previous character is A and the current character is A. So they are equal. And you don't want to include this A to the result. So just skip this A and then go to the next character and so on. So you will need a variable to keep track of the previous character, which is the prev character. And then you will need a variable result to store the result. And then you just need to iterate through the string and then keep track of the previous character. You have to always update the previous character. And then if character is not equal previous character, append it to the result. And yeah, if it's equal to the previous character, you can see there's nothing happened. So that means that it's not getting append to the result. Next. Okay, practice problems hard. So we have a deduplicate. So deduplicate is return the modified fraction. Again, return a new string that remove the duplicate words and keep only the first occurrence of each word and return the result. So for example, if you have hello word hello in capital universe, you should return hello word universe, because as you can see, hello occurred twice, so you just need to include one in the result and make sure to lower all the result. And then to make things easier, there's some precondition. So each word will not contain substring of any other words. Each word is not a substring of any other words. So, sorry. Suppose there is hello in the sentence, and there won't be the word hello or L or hell or O or L in the sentence. So it can make things easier for you guys. So the way to do this is that you guys have to find a way to somehow make a capital hello and lower hello to be equal. So the way to do it is that, why don't you guys just make it all lowercase? So instead of having a uppercase hello and lowercase hello, just make it all lowercase hello, so that the hello that is uppercase before is now lowercase, and then it's now equal to the first hello that is in lowercase. So first you guys need to like lower all the sentence, and you guys have to find a way to somehow break the sentence into words. So there's a way to do it in Python, because again, it's a common thing, right? Like breaking the sentence into list of words. It's a very common thing to do in coding. So there might be some methods. You guys can find it in the cheat sheets, the help sheets. It's called split. So first you lower the sentence and then you split. And then again, create a new string means that you have to have a result variable. You have to have a variable called result. And yeah. And then you guys need to iterate through all the other words. And then just make sure that there is no duplicate words in the result by using the in condition. Like if word is in result, then don't append it. If word is not in result, then append it. Like, yeah, append it. So result plus equal word, result plus equal blank space is just to append the word. And then note that if you do this for loop, in the end, you might have this little white space, which is not what we want, because we want it to be like no white space at the end. So you guys have to either strip or do R strips. Both are fine. All right, so far, any question? And then for your practice, you guys can remove this precondition and then just solve the problem without the precondition. It will involve a list and split. Yeah, basically all the same, but instead of using result is a string, you guys might have a list, and then finally you guys have to join the list by a space. Yeah, it's for you guys to practice. And then now we have while loop. So while loop will execute a set of statements as long as the condition is true. So while loop, you will have a condition to check and then a set of instruction to execute. So while, for example, while I less than 5, colon, I equal I plus 1. So it will like increase I by 1 until 5, I equal 1. So use cases for while loop. Use cases for the while loop is that if you want to have infinite loops for executing, it's useful for maybe input statement like making games, something like that. And then reading from files to EOF. This will be very useful for you guys because you guys will have a question maybe that will require you guys to read a file to the end of the file. And then it will be useful when you need to loop something until a condition is false. Yeah, obviously, yeah. And then there's a last while loop practice for you guys. Maybe I'll give you guys 2 minutes to solve. It's from the week 6 worksheet. Let's go while loops. All right, let's go through the solutions. And yeah, so yeah, you will have to provide two new examples. So just make sure it's not a duplicate of the previous examples. If you do it in the exam, you might get 0 marks for that. So it's useless to do that. Don't make a duplicate examples. And then, yeah, basically examples can be anything, but it will be nice if you guys can make it as unique as possible, like this. This one return an empty string, so it's like unique case, edge case, something like that. And yeah, find letter n times empty, x and 0. So because the text is empty, and of course it will return an empty string. Yep, and then find letter n times x, and the first that contains the first occurrence of the letter x. Yeah, of course it will be just x because s contains x and it is the first occurrence of x. And then for the solution, okay, for the solutions, all right, for the solutions, Okay, I think there's something wrong for the solutions, but let's just go through it. While count less than n, so while count less than n, hmm, well, you guys have not enough occurrence of the letter, then you guys have to keep finding the letters. Keep going through the string, and if you find a letter, then you guys increase the count by one. So that is what this if is trying to do. Like if I found a letter, I increase the count by one. And yeah, and then yeah, after count is equal to n, that means that count is not less than n. We can stop the while loop because the condition for the while loop is that while count less than n. So if that now count is equal to n, the while loop will be stopped, and then we will move to the return statement, return text colon I. So it will return the text from the beginning to the index I. Remember that index I will only be increasing. We only increase when count is less than n, up to count equal n. So after count equal n, I will like contain the index to the last the nth letter in the text. But what is wrong with this code is that this can result in an infinite loop if the count of the letter is not greater or equal to n, because you won't have count equal to n. So what we have to do here is that you have to add some condition to check that I is less than the length of the text. So we have to add a condition where I is less than length of the text. It needs to work. Can I edit this? I less than R. Yeah, it should work. So first, while count less than n and I less than length of text, so that means that count is now less than n. That means that you haven't found the nth occurrence of the letter, and I is still a valid index, so it's not out of the range like index. Suppose you have length of text of 12, but now your I is 13, so you cannot have that anymore because you have bound the I by length of text. So now you have to check that if text I equal letter, then count equal count plus one. So if it's equal to the letter, then you increase the number of occurrence by one, and then you keep moving forward by increasing the I. Then finally, you will end up in either when count equal to n, because the condition is count less than n, so the n condition can be count equal to n, or you will end with I equal to length of text. So if I equal length of text, that means you have not enough n, and I don't think there's a doxing to cover this case, but yeah, I think just do this is fine because you just have to finish this function. Oh, wait. Oh, there's a precondition that letter occur at least n times in text. So yeah, you don't need this. But if there's no precondition, you have to use this. All right. Right. Is there any question for strings and while loop.
Okay, if there is none, then we will pick it up in the second session after this at 7 p.m., where we'll start going over from tuples to dictionaries to file reading and until a bit of the runtime to cover the rest of the semester. The recording for this will be posted in the AMACSS community Discord, also with the corrected slides will be shared over there. If you have any questions about this review seminar session, feel free to reach out to us in the AMACSS community Discord. If there's no more questions, then see you guys later at 7 p.m. Thank you for coming. Yep, there's a Discord. I will share the link right now. So this is our community Discord link. And all review seminar related questions can be directed to the review seminar channel. That's where we'll also post the links to our recorded seminars and also the slides that were used in the seminar. Okay. If there's no more questions, thank you for coming and see you guys later.